So in today's video, the focus is going to be on fertilizers, which is part of Unit 3, and that's Chemistry and Society. And we're going to focus today on basically essential elements for plant growth, right? Things that help plants have strong roots, healthy leaves, healthy growth, essential elements for plant growth. And that's basically what fertilizers are. So healthy crops, of course, provide more food, and growing plants require nutrients, which are chemicals essential for healthy plant growth. And elements required by plants include things that are required by humans too, like hydrogen and carbon and oxygen. But most importantly for plants, we are thinking specifically of three elements, which are nitrogen, phosphorus, and potassium. And collectively, they're usually known as NPK, which is just each of the element symbols in order. So N for nitrogen, P for phosphorus, K for potassium. And they take these elements from the soil through their roots. That's how they have access to these compounds. And I should mention too that it's not just potassium, as an element, nitrogen as an element, and phosphorus as an element, but these elements are found within compounds that contain these elements. So for example, phosphates. So there's also some oxygen in there. Ammonium compounds, nitrate compounds, salts that contain potassium. So it's not just the elements in their raw elemental form, but as part of compounds that contain them. And a trick to remember these three elements, if you can't remember NPK, is to remember KP nuts, like a bag of nuts, because KPN contains all of those NPK elements that we have to remember. So KP nuts if you are stuck remembering NPK. So when we talk about fertilizers, what we're really meaning is that when the plants grow, when the crops grow, they remove some of these essential elements from the soil, since the crops are harvested to feed people and stuff like that. And the nutrients removed by the crops need to be added back to the soil so that the soil is healthy and can let more crops grow. And that is achieved by the addition of a fertilizer. And of these three, we're going to specifically focus on nitrogen-containing compounds, specifically ammonia and nitric acid, which are crucial in producing fertilizers. And they are very important compounds used to produce soluble nitrogen-containing salts, which can be used as fertilizers. So starting off, we have ammonia, which looks like this. It's a structure that we should be familiar with in terms of its shape from Unit 1, and its formula is NH3. And what we really need to know about it in terms of properties is that it's soluble, so it can be used to produce nitrogen-containing salts which can be dissolved in the soil. And it's also alkaline, or it forms alkaline solutions. So what we're saying is it can be also used with acids and neutralization reactions to produce these soluble salts. So that's how we get to what we need. So for example, we could have ammonia reacting with nitric acid, which also contains nitrogen, which would give us a really good fertilizer compound because it contains lots of nitrogen, so ammonium nitrate. Now, how did I know it would be produced like this? Because this is a neutralization reaction. This is an alkaline plus an acid. And when I do that, usually my rule is that I get a salt plus water. However, ammonia, we need to remember, is a special case. Water is not produced in this reaction because if we have a look at the chemicals that are used and the elements that are contained within them, there are no elements, no atoms left to produce this water. So this is a strange case of a neutralization reaction in terms of what we know at National 5 level. When we are reacting an acid with ammonia, yes, we do get a soluble salt, in this case ammonium nitrate, because the ammonia has changed to ammonium, but there are no water. So that's one that we have to remember. And we'll have a look in more detail in a future video at how we produce ammonia and nitric acid, because there are processes that we need to know a lot about in order to do that. But before we look at that, I'm going to look at a calculation that often comes up as part of this topic. It's included in Unit 1, but often exam boards like to ask this as part of a fertilizers question, and that is calculating something called percentage composition. So quite often, it's important for chemists to know the percentage of a given element within a compound, especially in terms of fertilizers, because we want to make sure that we are not making the soil too toxic. We don't want to add too much potassium or too much phosphorus or too much nitrogen or not enough of one or the other. So we need to make sure that say in a bag of fertiliser, which might contain all three of these elements, we want to get the correct ratio of nitrogen to phosphorus to potassium, for example. And the way that we do that is we use the mass of the element that we're interested in, and then the mass of the entire compound that we're talking about, so the gram formula mass. We do a little division of that mass divided by that gram formula mass, times it by 100, and that will give us the percentage of that given element within that compound. And if we forget that, that is contained on page 3 in the data book. So to have a look at a couple of examples here, we could have a very simple case where we might be interested in the mass of hydrogen in water. So of course, water contains hydrogen and oxygen, but we want to know, okay, by mass, how much of water is actually made up of hydrogen? What is the percentage of hydrogen out of all of the potential elements contained within water? So what we do is we take our gram formula mass, so we always find that first. So we have 1 oxygen times its relative atomic mass, which is 16 grams. You can find that in the data book too. Then we take hydrogen, which we have 2 atoms of, times that by 1, that gives us 2 grams. Total is 18. And then the mass of hydrogen is just all of the hydrogen that we have in the compound, which is, in this case, 2 grams. So, using our formula, we have 2 grams divided by 18 grams times 100. And if we put that all into the calculator, that gives us 11.11%. So what that tells me is, despite the fact that there appears to be double the amount of hydrogen compared to water, because there's 2 hydrogen atoms and only 1 oxygen, by mass, only about 11% of that compound is made up of hydrogen in terms of mass. And that's simply because oxygen as an atom is much heavier than an atom of hydrogen. So that tells us about the composition of water in terms of its masses and the ratio of masses of the elements contained within it. So if we look at an example that's maybe more relevant to this topic, we could be asked to find the mass of, for example, nitrogen within ammonium nitrate, the compound that we just looked at. And often in a question like this, you would be given the formula. You wouldn't be expected to remember something like that. So it's NH4NO3. And all we do is go through the exact same process. So we have our GFM to calculate first of all. So we have 3 oxygens, which of course have a relative atomic mass of 16 grams. We have 1 nitrogen here, which has a RAM of 14 grams. We have 4 hydrogens, which each weigh 1 gram, and then an additional nitrogen. So that's 1 times 14 again. And all we're going to do is put that information into the calculator, and we should find that we have 80 grams together for our GFM, so we can substitute that into our formula. Then, being very careful with this example, we have to look at the mass of nitrogen. Now, in this compound, there is nitrogen as part of the nitrate ion, but there's also a nitrogen as part of the ammonium ion too. So we have to include both of those atoms of nitrogen, both of the times that nitrogen appears in the compound. So we're looking at the total of nitrogen in the entire compound. So we take our 14 and we add on our other 14, and that gives us 28 grams in total for the amount of hydrogen by mass. So we can put that into our formula. And now again, going back to the calculator, we put 28 divided by 80, and we want to times that answer by 100, and we find that we get 35%. So that tells me that by mass, 35% of ammonium nitrate is made up of nitrogen as an element. And as I say, this is a common context for this type of calculation question to come up as part of a fertilisers question. So in summary, remember that not only do fertilisers contain nitrogen, phosphorus and potassium, but you might also be asked to work out a percentage composition of a given element within a compound that is used as a fertiliser.